Finally, the last section in Chapter 8, 8.8. We're going to take those systems of inequalities and use that for something we call linear programming. So to solve this, number one, you're going to sketch the region corresponding to the system of constraints. All right, that's your system of inequality. The points in the region or on the unbounded region are possible solutions. We're going to find the vertices of the region. This means where they intersect. We're going to test the objective function, usually traditionally given with a z equals, and we have some number times x plus or minus some number times a y. This is where we're going to test those intersecting points or your vertices into here. And we're going to test to see if our z is going to be a minimum or a maximum value if it exists. All right? So, my constraints, x is greater than or equal to 0, y is greater than or equal to 0. Again, that chops off quadrant 1. That's done. All right, now I have some very small numbers, so what I'm going to do is every two squares count as 1. 2, 3, 4, 5, 1, 2, 3, 4, 5. So again, quadrant 1, x is greater than or equal to 0, y is greater than or equal to 0. This is my quadrant 1. X plus 2y is less than or equal to 4. We'll do this in purple. Again, we can do our x and y intercepts. If I want to find the x-intercept, cover the y term, x equals 4, plot that point. Cover up the x, 2y equals 4, y equals 2, plot that point. Connect it, test the origin, 0 plus 0 is 0, and that's less than 4. Shade towards the origin. X minus y less than or equal to 1. We'll do this one in green. All right, we can find the x-intercept, cover up the y, x equals 1. There it is. Y-intercept, though, whoa, negative y equals 1. That's at negative 1, and I don't have that here on my graph. That's okay. All right, think about solving it for y if you want. Divide the negative, so I subtract it over the x. Divide everybody by a negative. And don't forget to flip the inequality symbol. All right, now, so my slope is 1. You didn't have to do this. You could have also said 1's in front of my x, negative a, negative 1 over b, negative 1 is a positive 1. That's your slope. So from this x-intercept, I'm going to go, all right, up one value of 1, to the right one value of 1. Plot a point. It intersects the purple line right there. I'm just going to cross it with my line. I don't have to go very far. It's the origin. If I continue this line down, there's the origin. 0 plus 0 is less than 1. So we shade in the direction of the origin. Or if you solved it for y is greater than, shade above the line. This is my solution region. All right, so now what we're going to do is we have to test the corners of our quadrilateral here that's shaded. And we are looking for a maximum value. So coordinates of this point, 0, 2. Coordinates of this point, 2, 1. Coordinates of this point, 1, 0. So I take my objective function, and I'm going to substitute in the points. 0, 2, all right, 3 times 0 is 0, 2 times 2 is 4. Then I'm going to test 2, 1. 3 times 2 is 6, plus 2 times 1, 6 plus 2 is 8. Then I'm going to test the 1, 0. 1 times 3, that's 3, 2 times 0 is 0, so it's a 3. Now, we can think logically here. You really didn't have to test the point 1, 0. Here's the reason. in this point 2, 1, 2, that x-coordinate is bigger than this x-coordinate of 1, and the y-coordinate of 1 is bigger than the y-coordinate of 0. So since this point is technically now larger than this point, and we're looking for a max, no reason to test it. Definitely had to test 0, 2. Yes, 2 is bigger than 0, but 1 is not bigger than 2, so we have to test it. So since 2, 1 generated a value of 8, that point at 2, 1 gives us the maximum value. Okay? All right, next example. Find the maximum and minimum value of this objective function, and holy cow, we have 1, 2, 3, 4, 5, 6 constraints here. All right, well, x greater than 0, y greater than 0, we know that's quadrant 1, so I'm just going to plop that in there real quick. All right, all my x's are counting by 1s. All right, let's take care of this first line right here. 2 and 3 divide into 6, so let's find the intercepts. Cover up the y, 2x equals 6, x equals 3. Cover up the x, 3y equals 6, y equals 2. Connect it together, test the origin. 0 plus 0 is 0. Is 0 greater than 6? Nope. So we don't shade towards the origin, we shade out into quadrant 1. 3x minus y less than or equal to 15. Well, let's see. I suppose you could solve this for y, but you're going to have a constant of 15 or negative 15, and that's not going to fit here. So let's do this. Let's find a point and a slope. Cover up the y. 3x equals 15, x equals 5. There's my point. And using my slope, negative a over b, negative 3 over negative 1 gives me a positive 3. So 1, 2, 3, 4, 5, and then up 3, right 1, plot a point. Up 3, right 1, plot a point, and I keep doing that till I fill up my graph. Test your origin. 0 minus 0 is 0. That's less than 15. So if you can imagine this blue line going down here, it's going to cross way down here, and so I'm shading in the direction of the origin. Negative x plus y less than or equal to 4. Again, still got a problem here because if I find my x-intercepts, it's negative 4. It's not here. So cover up the negative x. Y is equal to 4. And then find your slope. Negative 1 over 1 gives me a slope of 1. So opposite of negative 1 is positive 1 over the b, positive 1. So let's go to 0, 4, and then up 1, right 1. There's my line. 0 plus 0 is 0. 0 is less than 4. So again, this line continues in this direction. My origin is below it, so we're shading below the line. So everything appears to be fitting into this cone-like shape here. Now, hold the phone. I was going to go find the x-intercept, but 2 doesn't divide into 27 evenly, and 5 doesn't divide into 27 either. So my x and y intercepts would be fractions. That would be really difficult to want to graph. So here's a shortcut. Look to turn these numbers multiples of 2, multiples of 5 that can add up to be 27. All right, so here's what you can do. You can say, well, since 2 is an even number, and if I take this 5 and subtract it over to 27, that would make 22. and that would 2 can go into 22 11 times. So I had 1, 5, and I can find that point. Or I can take x, let it be 1, that's a 2, subtract it from the 27, that's 25, and 5 goes into 25 5 times, which means y is 1. So I can go to the point 1, 5, which is right there, and then take the slope opposite of a, negative 2 over b, 5, down to right 5. And there's my line. I could go further. Okay, if I did go down to right 5, 1, 2, 3, 4, 5. Remember I said this could be 22. 2 goes into 22 11 times. And I had 1, 5. Y is 1, so there's the point 11, 1, also on that line. Test the origin. 0 plus 0 is 0, less than 27 true. This is my solution region right here. All right, so let's go find our vertices. So we're at 1, 5. We're at 6, 3. Let's go find our maximum points. Again, another pattern would be find the vertices that are the furthest away from the origin. Now, the points on the y-axis and the x-axis here. Again, this is 0, 4. I don't have to test this point for the max because 1 is bigger than 0, 5 is bigger than 4. This x-intercept at 5, 0, I don't need to test it for the max. 6 is bigger than 5, and 3 is bigger than 0. So I really need to just test these 2 points. So take your 5x plus 7y. Let's test 1, 5. 5 times 1 is 5, plus 7 times 5, 35. 5 plus 35 is 40. Test the point 6, 3. 5 times 6 is 30, plus 7 times 3, 21. Gives me 51. The point 6, 3 is the point for the max of this objective function. Now, for the minimum, now we want points not furthest away from the origin, but we want points closest to the origin. We're looking at 0, 2 and 3, 0. Again, I don't have to test this point at 0, 4 because 0, 2 is closer than 0, 4. Same thing with 5, 0. 3, 0 is closer. So I'm going to test 0 and 2, 5 times 0, 0, 7 times 2, 14. Test 3, 0, 5 times 3, 15, 7 times 0, 15 plus 0, 15. 14 is the smallest, 0, 2 is the point for the min. Now, sometimes the closest point to the origin, which is 0, 2, may not give you the minimum value. So, for example, if we had this 7 was an 8, 8 times 2 is 16, and now 16 is bigger than 15, so even though 3, 0 is further away than 0, 2, it's just that the 3 gets multiplied to the 5, which is smaller than having the 2 multiplied to, again, say an 8. So you still have to test the points. All right, and that wraps up the last of 8.8.